Swayam Prabha. Digital India. Educated India.
I am Amit Kumar, Professor in Department of Aerospace Engineering, and I'm also a part of a National Center for Combustion Research and Development. Here I look after the microgravity dock tower. This is a unique facility in India. This is the first and the only facility in India where we do what is called zero gravity tests. So we get a glimpse of what happens in space. So when we go to space, there is no gravity, and so that we achieve by actually dropping a material or the experiments from the top, which is dropped from a height of about 38 meters. So when it's falling, it's under no force, and we experience like 2.5 seconds of space environment. So this facility allows us to do our experiments for whatever is happening in space, to understand things are happening in space. With the current missions, human missions to space, where India is also becoming a player. So this research becomes very important because many things are counterintuitive, which we don't see here, happens over there. So because we are used to normal gravity, we are used to seeing things fall down, but then when you go to zero gravity, there is no falling. Water falls down. If you want to extinguish fire, you want to throw water, but you cannot do that in space. When you are in space, there is no gravity, so plumes don't go up. So everything actually changes over there. As people say that is, water, you can drown in space more easily than on Earth because buoyancy helps you to come to the top, but there is no buoyancy there. So there are like many things which are counterintuitive, and for every day-to-day life, when people are living there, you need to understand how things are happening. So this facility helps us to understand those things. For example, the setup which you see over here is about manufacturing in space. Because now when people live there, we cannot carry everything over there. So we need to build things there. We may need to make things there. So this is a setup where we do 3D printing. So this is for testing how 3D printing will help in our work in space environment where there is no gravity. Because whenever we have welding, the droplets go down because of gravity, and then some gases come out, but all those things get influenced because of gravity. So how the quality of welding or 3D printing would be in space. So that we study here. Similarly, materials burn very differently. So all our materials are qualified based on tests on the Earth. But researchers have shown that material can behave very differently in space. The materials which will qualify as not burning here may become burning in space environment. So which means that there is no other way but to do tests in space environment. So that's where this facility, this setup actually is doing some tests on that, flammability of materials in space. One more experiment which we are recently started to do is about soot generated when there is a fire, because our fire detectors detect this particle size based on which they give signal. Now the particle size can change in space environment because in normal gravity there is a plume which goes up, and the soot particles size, they agglomerate and they become of different size. In zero gravity, the sizes are different. So know what those sizes are, we again use this facility to find the size of the soot particles, and when we know those soot particles, then the smoke detectors or particle detectors can be designed accordingly, so that right kind of signals are predicted. We don't get false alarms, or we don't not detect the fire. This is the 4th tallest tower in the world. The tallest one is in Germany, followed by the second one is in NASA Glenn Research Center, third one is in China, and fourth there are two towers of same duration. That one is in IIT Madras and second one is in Japan. So this makes this facility quite unique and a facility which is, you know, not available elsewhere, but because it's available here, it's available to, you know, people, all the students and researchers within India. So anybody can come here and do the experiments. So there are various platforms for doing this microgravity tests. The obvious one, what the one people say is to go to space station, but that's very expensive. Not only it's expensive, you have to have a long duration of wait, because there are many other people in line and it has to go through many qualifications before you can actually go to space. The second platform is to use rockets or aircrafts. The problem with them is that they require full rocket to be there, and you have to have a recovery plan to recover your setup, or you lose the setup. Aircraft again is very expensive. You have to rent the whole aircraft for your experiments. So for renting, it's tens of lakhs for just few hours. So in that context, this drop towers become very cheap and easy access to space. That's why they're called windows to space, or you get a glimpse of space. So here within few thousand rupees you can do one test. So one can do hundreds and thousands of tests at a very low cost, and it's very affordable, and students can do it. You know, anybody who has interest in space and they want to do some research in microgravity, they can use this tower. There are already, because as the human endeavors in space increases, more and more there is need for doing these tests, because we are not used to space environment. We don't know how things will behave. There are many, we do a lot of research on Earth because we don't know many things. And when you are going to space, we have an additional parameter of no gravity and no experience. Very little experience, because people have already gone, but very little experience. A new situation is always a new situation. So there is a lot of requirement for research, and there are many private companies coming, and if they can provide a platform for large duration microgravity test, that is something people are all looking for, affordable. So as I said, you know, this is very cheap and accessible. All other platforms as of now are very expensive. So aircraft, so tens of lakh, going around 1 crore, one test, a 1 day test. And similarly rockets, several crores. Space station is time as well as cost, very expensive. So this is an accessible platform, but we are looking for, there is a need for longer duration accessible platforms. So if those planers, like we have a startup here, E-Plane for example, so they can go in that direction of providing us a platform for, you know, 20 to 30 seconds of microgravity time, if they modify their you know, aircraft for that kind of flight trajectory. And then we write our programs, because we have short duration, but if you want to predict what will happen further, we develop our programs. So we write our codes to predict what would happen later. So this is basically to verify our codes are working fine, but once we have verified our code, then we use our codes to predict things for a longer duration. So that capability also we have here. Each drop takes around 1.5 hours. So that way we can go up to 9 to 10 drops a day. So 9 to drop experiments a day can be done.